ready? So at this point, you should have read pages 25 through 29 of your geometry packet, and we are going to be working our way through understanding what those graphs look like of just the sine, cosine. That's just a little bit of an extension at this point. So there was a question on the bottom of page 26, and it says, is the sine function even, odd, or neither? And what you need to memorize is that the parent sine function, so sine will always start at the center line, increase, decrease back to the center line, and then decrease all the way down to your minimum and come back to the center line. You will need to memorize that, and then the fact that the cosine is a little bit different. So it will start at the maximum, go down to the minimum, come back to the center line, and finally come back up to the maximum value. Now, those are going to repeat over and over and over again. So the reason why sine is odd is because we've talked about how you can rotate 180 degrees. So I'm going to go ahead and do that. So I'm going to put my pen here. It's probably going to bleed through. That'll be all right. And if I rotate, I get the exact same graph. It did bleed through. Not too bad. All right, so that's my sine graph. So it's a rotation of 180 degrees on the origin, or you can think that opposite inputs have opposite outputs, whereas the cosine will be even. So this one is odd, this one is even. So the parent cosine function is even because it's a reflection over the y-axis. Opposite inputs have the same output. Okay, you can review some of that with even and odd functions. All right, then over here, you can go through all the characteristics. Domain will always be all real numbers. The range is going to be the interval inclusive from the minimum to the maximum. That will pertain to your A value, and we'll look at the transformations in a minute. The center line or the midline is a line that the graph toggles around. So it's going to keep going above and below over and over and over again because these are periodic graphs. Another phrase that you might hear is that they are sinusoidal graphs. And then they're talking about the period for one cycle is going to be 2 pi. And then all this is saying is that you hit the maximum value an infinite number of times and you hit the minimum value an infinite number of times. All right, I'm going to skip about finding all t values. That's solving, and we're not going to get to that for quite a while. So let's go over to page 29 here. And I would encourage you to highlight here. Apparently, I can't find the highlighter at the moment, but you can highlight, you can make note cards for yourself. All of this you're going to need to memorize. Okay, you need to memorize what the parent function of the sine and cosine look like, and then these basic transformations. And some of you are really smart. You might say, A, B, D. What's up with that, Mrs. Levine? What happened to C? Well, C is going to pertain to horizontal phase shifts, and we're going to get into that next week. So A is the height, the amplitude of the function. We're always going to look at the absolute. That kind of messed up in the last video, but you're just looking at the stretch. D is going to shift the entire graph up and down. And then, if A is negative, it will be a flip. The period of the wave is going to be 2 pi over B, and B is the number of complete waves between 0 and 2 pi. So what I'd like to do is go over to B. Okay, and they're asking us to compare the graphs of sine of t and sine of 2t. So as you go through, you're kind of looking at your values here. Okay, so for question 3, we are comparing the graph of the sine of t for f of t and g of t, the sine of 2t. So f of t is our parent function, so that's pretty straightforward. G of t is having 2 waves between 0 and 2 pi. So we input here. So I want to know, what do I multiply by 2 to get pi over 2? So that my maximum value is 1. And if you think about it, that's going to be pi over 4. So you're going to have pi over 4 times 2, and that'll get you pi over 2, so then your output is 1. And what do I multiply by 2 to get pi? And that's going to be pi over 2. 2 times pi over 2 is pi, and then the output would be 0. And then you're going to kind of continue that pattern. So here you're going to get 3 pi over 4. So 3 pi over 4 times 2 will give you the 3 pi over 2, and then that'll give you your minimum value, the -1. And then to get 2 pi, if this is 2, obviously, hopefully, it's probably not that obvious. This pi, and you're going to do 2 times pi to get 2 pi, and then you're back to your center line. So what that looks like here is I have my halfway point here at pi over 2. I have a full cycle at pi, and then at pi over 4, here I have the max. And then at 3 pi over 4, I have my minimum, and then you connect. And then remember, it's periodic, so then you would just kind of continue the cycle and do a whole other round. It would continue infinitely. It doesn't have to be perfect. Mine doesn't look perfect either. You just kind of have to show that you're getting that nice curve right there. And then this curve, remember, is coming from our unit circle. So if we wanted to throw on pi over 6 and pi over 3, you could. And do it out point by point to get all of those specific points in here, which I'm not asking you to do. And those go back to those decimals that I showed you with the calculator. Okay, take a moment and write this cheat sheet at the top of your table here for question 4, and I pause it for a second. Okay, what I'd like to do with you is I'm going to do letter C first, and then have you pause the video and to do A, B, D, and E. But I'm going to talk through it, so I would just encourage you to pause it when you can. So we have f of t equals 3 times the cosine of 2t plus 1. So A is 3. A is always the absolute value. So you're doing the absolute value of 3 to get 3. So is your height. So that's your distance from the center line. So how far are you going to go up? How far are you going to go down? B is the number of waves between 0 and 2 pi. So you have 2 waves between 0 and 2 pi. So this one's a cosine function instead of a sine function. So just above, I showed you double time for sine. This one would be the same, except remember the cosine starts at the max. For the parent, goes down halfway to the minimum and back up to the max. If this was negative, it would be the opposite, and it would start low and go high and then end low. All right, now what is a period here? We're going to do 2 pi divided by our B value. And that's saying that you complete 1 wave in pi units, in pi radians. All right, your center line will always be written as an equation. So I have y equals 1. Line. For both sine graphs, the sine graph and cosine graph, the domain is always all numbers, and we're going to use soft brackets because infinity doesn't actually have a value. So I'm starting at negative infinity, and I'm going to positive infinity. Your range is going to be d plus a as your maximum, d minus a as your minimum. So if the center line is at 1, you would go down 3. So 1 minus 3 is -2. So you're going to start at -2 inclusive for your minimum. And then you're going to do the d plus a. So 1 plus 3, get your maximum value of 4 inclusive. All right, those columns aren't too bad. This column over here, the even, odd, or neither, is extremely challenging. It's kind of a gotcha. It doesn't seem like it should be as hard as it is, but I personally find that really hard to figure out, and I had to kind of get my head around this because I haven't really looked at this in a year. So you have to think. There is not one quick thing that I say, oh, is the function even, odd, or not, neither, and just have one set of rules, you really have to think. Even for linear functions, you have to think. If you think of a horizontal line, horizontal lines are even, but the line y equals 3x is odd. But if I did y equals 3x plus 1, it's neither, because you're now up a little. So here I have f of t equals 3 times 2t plus 1. You haven't graphed any yet, but we are going to be doing that in a minute. So this is going to be stretching it. This is going to make it go faster, and this is going to make it go up. So what happened is my cosine function, remember, it starts high and then it goes low. So it's stretched out a little bit more and it's going to go faster. Okay, and if you look at that, so it's stretched more, it goes faster, but it's been lifted up 1 unit. So it's kind of a big unit. So now this is at 1, so then this would be at 2, and this would be at 0. So this graph is actually not very good. But you know what? I'm not going to re-record it because that's not the point. The point is that you think, and this is going to happen to you. So I want you to see something authentic. So if I did it again now, it would actually be more like this. And that's going to happen to you. Okay, so here's your center line. Your center line's at 1, this is 2, and this is 0. That's not the point. These even, odd, and either questions aren't necessarily looking for perfection. They're looking for you to think. And now, by the definition of an even graph, it is graph symmetric to the y-axis. That's the point. And yes, it is. So this one is even. So ask yourself first, is it even? If it's even, then it can't be odd or neither. There's always only one answer. Odd would be symmetric to the origin, which is that 180 rotation, and then neither would be many graphs. It just kind of depends on what you have. Remember, the other alternate definition is opposite inputs have the same output. So if I went out here, you're getting the same output either direction. Okay, so pause it, try A, B, D, and E. Okay, let me go through and kind of talk through this. So you're going to have one wave between 0 and 2 pi. Your amplitude would be 2. Here, your period is like the parent, it's 2 pi. Your center line is going to be y equals 0. All of these have the same domain, so actually domain is great. That wasn't a very good looking infinity sign. So that part's easy. And once you get the hang of these ranges, it's not too bad. So for the range, you're starting at 0, you're going up 2 and down 2. So this is going to be -2 to 2. Maybe you wanted me to do another one before you tried them on your own. So feel free to pause at any time to try your own row if you want. All right, for letter B, you're doing the absolute value of the -1. So that's going to be 1. There are 4 waves between 0 and 2 pi. So those of you who are musical, it's not double time, it's quadruple time. And now that means it would be 2 pi over 4. So pi over 2 would be your period of 1 wave. So that's going pretty quick. Center line, again, there's no add-on, so it's going to be y equals 0. And then your range is just going to be going from 0 down to -1 and up to -1 to -1 to 1. Notice I'm skipping the even, odd, and neither, and we'll go back to those in a minute. All right, for letter D, your absolute value of A is 5. The number of waves between 0 and 2 pi is B, so it's going to be 1/2. And then your period is going to be 2 pi divided by 1/2. So that will be 4 pi. All right, center line is y equals 0 still. And then your range, you're just going to be going up 5 from 0 and down. So -5 to +5. And again, I'm skipping that for the moment. And then amplitude, hopefully these are getting easier for you. You're going to be doing 2 pi divided by 1, so that's just 2 pi. Your center line is y equals -4. Make sure you write the center line as an equation. That's important. And then you're going up 1/2 from the -4 and down 1/2. So you're going to start at -4.5 and go up to -3.5 inclusive. Okay, so now is the function even, odd, or neither? So for letter A, you have the parent sine function. The parent sine function is odd. It's just got a vertical stretch that will not affect the fact that it's odd. And you basically have this example right here at the top to kind of show that. All that's happened is it's stretched out. So this one is still odd. For the letter B, you have the parent cosine flipped upside down, and it's going faster. So if you think about the graph of that, you have the parent cosine flipped upside down and going faster. So I'm going to kind of show you what that looks like. So for B, it's upside down. So you're going to start at the minimum and go here, and it's just going a lot faster. So it's cosine. So the cosine is even for the parent, and it's still even. So your opposite inputs still have the same output. So this one is still even. Okay, now the sine function down here for letter D, I have a bigger stretch, and this one is going slower, but that's not changing anything else. So this one is still going to be odd. So your opposite inputs will have the same output. But for letter E, now if you look at that, so my stretch is a little bit less. It's the same period as the parent, but I shifted it down. So when I shift down a sine function, so remember the sine starts at the center line. So this is going to be a little flatter. So I'm down at -4, and if -3, -2, -1, I wish I gave myself a little bit more room. It's not a big deal. These do not have to be perfect. But now I'm kind of going like that. So it's sort of flat. And if you look, that's certainly not even, and it's no longer odd because it's been shifted down. So this one's neither. Okay. The other things I just wanted to mention to you as you look at these graphs, and I'm going to go up to question 3, is we have all this old vocabulary from our polynomials. So you have increasing intervals and decreasing intervals that go on forever. They're infinite. So here you would have an increasing interval from, I guess this would be 3 pi over 4 to 1 1/4 pi, so it's 5 pi over 4, and do your increasing interval there, and then decreasing would be from here to here, and then that would repeat over and over again. And then do you remember the vocab word for our maximum values and our minimum values? Well, I think they're extrema or extrema, depending on how you pronounce it. So I've heard both. We actually talked about that at a department meeting recently. So extreme values probably would be the extrema or extrema, but those are where those would fall at all the max and minimum. And you have an infinite number of those in our sinusoidal graphs. All right, let's go over to page 31. And let's look at the graph of one of these. So this is a cosine graph. So we have f of t equals -2 times the cosine of 3t. And I would kind of go through your A, B, C, D, except in this case, we haven't introduced C yet. So A is -2, B is 3, and D is 0. There's no add-on at the end. Okay, so the fact that A is negative, it's flipped. But your amplitude, you're going to kind of go through that list that we just did. So the amplitude is 2. Your period is always going to be 2 pi over B. So that's going to be 2 pi over 3, which is a little bit unusual. Because B is 3, there are 3 waves between 0 and 2 pi. The next part is the interval. Each interval, and intervals are going to be your values for your x-axis. Each interval will equal the period divided by 4, or a quarter of the period. And I would highlight that. Okay, so each interval is a quarter of the period, or the period divided by 4. So in this case, our interval would be a quarter, 1/4 of the 2 pi over 3. So the 2 and the 4 reduce to 1/2, and in the numerator, you're going to get pi over 6. So 1 times 1 pi is pi, and 2 times 3 is 6. So each interval is pi over 6. All right, so let's take a look down here for our amplitude. And you're going to go, the center line is 0, so D is 0. I always like to do the y-axis first because the y-axis is pretty straightforward when you graph. So you're starting at your center line, and then you're going to go up to 2 and then down to -2. You can put these values in if you want. You can kind of the first time, but I would say in general, you're probably not going to do that too much. All right, because we're only going to be doing the center line values, the max and the minimum. You don't have to do all of them. All right, so the parent will start at the max of the cosine, but this one's minimum, so you're actually going to start down here. All right, and at the first interval, I'm going to start at 0 here, and I'm going to go over pi over 6. So now I'm going to my center line. And now I'm actually doing pi over 6 plus pi over 6. That's going to be 2 pi over 6, which is equivalent to 2 pi over 3. So that's going to be my max value. So each part, I'm adding pi over 6. So when I add pi over 6 here, I get 3 pi over 6, which is pi over 2. So now that's going to be my center line value. And now I'm going to add pi over 6, which is easier to do from the non-reduced fraction, and you get 4 pi over 6. Okay, and that reduces to 2 pi over 3, and that's going to come back down here. And then you would just keep repeating. So then you're going to add pi over 6 to get 5 pi over 6, 6 pi over 6 to get back to your max, add pi over 6, 7 pi over 6, 8 pi over 6, 8 pi over 6 reduces to 4 pi over 3, and then 9 pi over 6, which is going to be 3 pi over 2 because they're both divisible by 3, 10 pi over 6, 11 pi over 6, and then 12 pi over 6. Okay, and then you're just going to keep plotting those points. I feel like it's not too bad to plot the points. I think what's really hard to do is to draw the nice curve. So I'm going to just kind of come through here, and here's 1, there's 2, and there's 3, and I'm not surprised by that because I started at 0, and from the interval from 0 to 2 pi, I said there's going to be three waves. All right, so here's my first wave, my second wave is completed here, and then this is my third wave. Okay, so hopefully this helps. After this, hopefully you can go on and try the homework questions, and then I will see you at our meet. Take care, guys.